This is, I think, is a hack. So this is what Andrey put together. So he's based over in Russia. He was one of those surprise entries last year that nobody had any idea, and then it came through, and it was a really good hack. So he's submitted WebRTC computer vision. So we're going to play his video, and then we'll do some Q&A over Hangout, okay? So I'll just fire off his video.
Hello TADHack, my name is Andrey Zakharchenko. I'm a fan of WebRTC technology, and in addition to that, a technical sales consultant at Oracle Russia. For TADHack event, I have created a WebRTC application integrated with computer vision analytics. The application analyzes a video stream from user's web camera and performs several actions. If the user's face was not detected during a media content playing, which means the user was not looking at the screen, the app advises the user to replay some parts of media content. The application also notifies the content owner, a user who is sharing the content, whether the viewer is watching the content or not. One of the use cases of this application can be a scenario of online webinar. Then the presenter will be notified in near real time about how many viewers are really watching the screen of the application. Architecture of this service consists of several components. The WebRTC application provides user interface and gets user media from browser. Application running on a web server hosts the WebRTC application and implements service logic and video analytics. The service uses Oracle WebRTC Session Controller for signaling and media processing. Another component, Dialogic XMS Media Server, performs recording of video streams and delivers video files for face detection processing to the application on the web server. Application on the server utilizes OpenCV library for video analysis. Video analysis is a very CPU-intensive operation. This is a very important fact if a WebRTC app is running on a mobile device, and it can consume lots of battery power. I decided not doing video processing in user browsers, and instead of that I do it on the web server. To connect audio and video streams, I'm using XMS Media Server from Dialogic. For video processing in OpenCV library, the XMS server records and transcodes video streams from DP8 to H264. My demo application has a simple user interface. User A, a tutor, is watching a training video together with user B, a student. The training video is playing in YouTube video player and synchronized between browsers. If the student has a question, he can stop the video and discuss it with the tutor using WebRTC technology. At the same time, the video stream from the student's camera is being processed by web server. If the student is not keeping attention to the video, checking his mobile, for example, or napping on the desk, the app will notify the tutor and advise the student to replay the content, as he may miss some important information. Let's simulate the student's behavior. As you can see, the application notified the student that he may need to review the content. Similar notification as you can see here for the tutor. Thanks for watching. Bye.
That was fun. Here we go. Sorry about that, Andrey. We were
That's okay.
playlist was driving me crazy there. Okay. Do you have any questions for Andrey? Go for a chat.
Hey, Andrey, it's Chad from TADHack. One question, why did you have to transcode? Is that because OpenCV doesn't support VP8?
Yes, that's true.
Cool.
Can I get
Yes.
to my 16-year-old son?
One of the audience asked, can he get it for his 16-year-old son? So it's good commercial potential there. Any other questions, James?
Yeah, what's the mechanism that you're using to do the face detection?
Well, it's a pretty standard face detection mechanism available in OpenCV library. I tried several methodics how to detect, for example, eyes and nose. The problem is that if you wear glasses like me, it is very difficult to find out eyes on the face. So I decided to detect on the face characteristics, not noses and mouth, because it's quite difficult to detect.
Okay.
Excellent. Go on, Tim. Last one.
Did you benchmark running it on OpenCV on the mobile device?
No, I don't.
Okay.
But looking at the performance on my laptop, I would say it will. Well, it depends how quickly and how short period you want to check the face. It depends on how many times you need to run through the algorithm, and if you want to do it, for example, maybe several seconds or maybe minutes, that will maybe consume a lot of power. So I decided to do it on the server.
Okay, go for it, Matt. Just one more question.
Yeah. So for the application server that is taking the H.264 stream and putting it into OpenCV, does OpenCV come with its own RTP stack? And what we're using for signaling between the Dialogic server and the OpenCV jig?
Well, the architecture is the following. I have a Python script which is, let's say, creates a recording on XMS server and gets video files, and video files then processed by the script.
Okay.
And if, for example, we figure out that there is no face, I send a message through PubNap network to WebRTC client so that we can notify the viewer and the tutor that something is going on.
Thanks. That's really cool.
Excellent. Let's show appreciation for an excellent hack from Andrey. Thanks again. Well done. That was excellent. Thank you.